We're going to, in this video, look at 3 different rational functions and decide what to look at to figure out their end behavior. In other words, the long-run behavior to the right and the long-run behavior to the left. Just as with polynomials, usually only the highest power seems to matter. In the next video, we'll actually talk in some detail about why that's true, but meanwhile, we're just going to use it. What I want to do, if someone talks about just end behavior, remember, this doesn't apply to all the wiggly stuff in the middle. We just want to look at the leading term on top and the leading term on the bottom. And we're just going to put a little squiggle that says this is about the same as, I'm going to get 5x cubed on top. I'm going to get 2x on the bottom. And so that's going to look like 5 halves x squared. Well, we know what 5 halves x squared looks like. That's a power function that just looks like this. That's just a parabola. So we see that way to the left, the graph is way up. Way to the right, the graph is way up. And the way that we usually like to write this is, well, they'll write x arrow minus infinity, but that really just means way to the left. And then they're going to write y arrow infinity, and that just means way up. So you don't want to read this as x arrow goes to minus infinity, that y goes to infinity. We really just want to read this as way to the left, the y values in the graph go way up, and way to the right, the y values in the graph also go way up. And so that's just the end behavior of our first example. Let's look at the second example. Second example looks like y equals, and I get 12x to the 5th minus 7x squared, x to the 5th minus 7x squared, I think it was plus 1. And on the bottom, I see 4x to the 5th, and then minus 2x cubed, plus 5x. And remember, we're talking only about end behavior. There's going to be a lot of weird stuff going on in the middle. But meanwhile, way to the right and way to the left, the only thing we need to look at is the leading term on top and the leading term on bottom. And so we'll just write that this is approximately the same as 12x to the 5th on top, 4x to the 5th on bottom, and the x to the 5ths cancel, and actually well, all we get is 3. And what does that say? That says when we zoom out way to the right and way to the left, we can't tell what's going on in the middle, but the whole graph is going to look just incredibly flat. Now what do we mean here? We're going to say way to the left, the y values get very close to 3. And way to the right, the y values also get close to 3. You can see, by the way, that that's a horizontal asymptote. And what we mean by that is way to the right and way to the left, that the y values on the graph are getting very, very close to the y values on this line. All right, that's the second example. So the first one, we had end behavior of going way up. On the second one, we had end behavior of a horizontal asymptote. For our last example, we're going to look at 5x cubed minus 2x plus 1. And then x to the 7th plus x minus 4. And remember, all we're asking is what happens to this graph when we zoom out way to the right and way to the left. Well, this is a rational function, so all I have to do is look at the leading term on top, leading term on bottom, and then we're going to write is approximately equal to, not true about all that wiggly stuff in the middle. I know I keep saying that, but this only describes what's going on way to the right and way to the left. So I'm going to get something that looks like this. And then the x cubed cancels, and I get 5 over x to the 4th. Well, we know what that looks like. That's from our zoo of functions. It looks like this, and it looks like this. For what it's worth, in my calculus classes, I usually call it a volcano. You can call it what you want, but I think that's pretty apt. What do we want? Well, as we look way to the left. What's going on with the y values? They're getting very, very tiny. In fact, they're getting just very, very close to 0. If I go way to the right, what I'm seeing is the exact same thing. As I walk along the graph further and further to the right, those y values are getting tinier and tinier. And so here, I actually get another kind of horizontal asymptote at just y equals 0. So there are three things that can happen. You can either have y's getting big, you can have y's getting close to some specific non-zero value, or you can have y getting close to 0. And those are the only different kinds of things we're really going to worry about.